Hello everyone, welcome to the second part of this chapter. In this part, we are going to actually talk about how to manage the risk. Basically, risk appetite, or sometimes we know it as risk tolerance, is the quantity and nature of risk that the company is willing to accept as they basically evaluate the trade-off between perfect security and unlimited accessibility. The reason approach to the risk is the one that kind of balances the expense in terms of finance and the usability of information assets and against the possible losses if it can be exploited. So a firewall vendor might install a set of firewall rules that are far more stringent than necessary, simply because they are being hacked. It could jeopardize its market. Some other company, maybe they take on dangerous risks because of the ignorance. When sometimes the vulnerabilities have been controlled to the degree of the possible, there is often remaining risk that hasn't been completely removed, shifted, or maybe planned for. In other words, we can call that residual risk. So residual risk persists even after safeguards are being implemented to reduce the level of risk that's associated with threats, vulnerability, and the information assets. So even after the company has implemented the policy, education, and training, and technical controls and safeguard, residual risk is the amount of risk that remains after even the organization has taken all of these into the consideration. So this is basically, this figure explains how residual risk persists even after the safeguards are being implemented to reduce the level of risk that's associated with threat, vulnerability, and information assets. So the goal of the information security is not to bring residual risk to zero, rather than it's bringing it in line with the organization risk appetite. If the decision makers of that company, maybe the the CEO or CIO, or maybe the managers, have been informed of the uncontrolled risk, and proper authority group within the communities of interest decide to leave the residual risk in place, then the information security program has actually accomplished one of the primary goals. Here are basically some rule of thumbs for selecting a strategy. When a vulnerability exists in an important asset in your company, implement security control to reduce the likelihood of a vulnerability being exploited. When a vulnerability can be exploited, apply layer of protection, architectural design, maybe administrative control to minimize the risk or prevent it from happening again. When the attacker's potential gain is greater than the cost of the attack, apply protection to increase the attacker's cost or reduce the attacker's gain by using technical or some sort of a managerial control. And when the potential loss is substantial, apply design principles, maybe architectural designs, technical and non-technical protection to limit the extent of the attack that could happen. Therefore, you are reducing the potential for the loss. Basically, this shows the process by which the company chooses from among the risk control strategies. In this diagram, we can see after the information system is designed, we can determine whether the system has vulnerability that it can be exploited. If there is a threat exists, we can determine what an attacker will gain from a successful attack. Then we can estimate the expected loss that the company will occur if the vulnerability is successfully exploited. If the loss is within the range of loss, the organization can basically absorb it. If the attacker gain is less than the likely cost of executing the attack, then the company may choose to accept the risk. Otherwise, it can use the other other strategies that are there. After we selected or implemented a control strategy, these controls, they should be actually monitored and measured on an ongoing basis to make sure that the system is effective and basically, we can estimate the remaining risk. So at the minimum, for each information asset or maybe threat pair that was developed in the risk assessment that we created previously should have document control strategies that identifies any residual risk that can remain after the proposed strategy have been executed. Basically, this is a risk control cycle that is making sure that the risks are being controlled. So if we follow this plan, then we can kind of make sure that we have implemented the risk control plan and we are making sure that the risks are being controlled. Now let's look at feasibility and cost-benefit analysis. Before we can decide on the strategy for a specific asset vulnerability threat combination, all readily accessible information about the consequence of vulnerability has to be explored. Basically, what are the actual and perceived advantages of implementing a control, as opposed to actual and perceived disadvantages? So, while we are looking at the advantages for a specific strategy, we need to identify the number of ways. The primary way is to determine the value of information asset that we want to protect. Cost avoidance is the money saved by using the defense strategy by implementing a control, by eliminating the financial ramification of an incident. One of the common criteria that we use when we evaluate a project that implements information security control is basically economic feasibility, if it's feasible economically for us. The company can begin this type of economic feasibility analysis by valuing the information assets and determining the loss in the value if those information assets are being compromised. This decision-making process is basically called CBA, or cost-benefit analysis, or another word is we can use economic feasibility study. So we need to kind of find out if it's worth it for us, if it's economically feasible for us. So let's look at what is cost. Just as it could be difficult to determine the value of information, it's also difficult to determine the cost of safeguarding it. Some of the items that can affect the cost of a control is basically, one of them could include cost of development or acquisition of the hardware and software. We need to also include the training fees, also cost implementation, service costs that could be associated with it, and cost maintenance, such as labor expense or to be able to verify and continuity of the test, maintaining it and training it and updating it. Benefit is the value of the organization of using control to prevent loss associated with a specific vulnerability. It is normally determined by valuing the information asset or asset that are being exposed by the vulnerability, and then we can determine how much that value is at the risk and how much risk exists for that type of the asset. This is actually called ALE, which is annualized loss expectancy. Now that we kind of understand the cost and benefit, now let's look at asset valuation. So basically, this is a process of assigning financial value, or basically the worth, for each information asset. So the value of each information is also different within the organization. Asset valuation involves the estimation of the real and perceived cost that could be associated with that asset. It can be selected from those that are associated with the design, development, installation, maintenance, protection, recovery, and also the defense that is against the loss or litigation. Some costs are easy to determine, such as replacing a network switch maybe, or some cost of the hardware that we need. Other costs are a little bit hard to determine, such as the dollar value of the loss in the market share if that information on the company's new product offering is released prematurely and that the company loses its competitive edge. So that's hard to determine. Some of the components of asset valuation, it could include value returned from the cost of creating the information assets. That means information is created or acquired at a cost which can be calculated or estimated. Let's, for instance, maybe a company have developed cost accounting practices to capture the costs associated with collecting and processing data, as well as the cost of developing and maintaining the software. Software development costs, it could include the effort of a lot of people that are involved in the system development lifecycle for each application and system. Value returned from past maintenance of information assets. It is estimated that for every dollar spent to develop an application or acquired and process data, many more dollars had been spent on maintaining it over the useful life of data or software. And then value implied by the cost of replacing information. The cost associated with replacing information can include human and also technical resources that need to restore or regenerate those information from the backup or from the transaction log or hard copies of data sources. And then we have a value acquired from cost of protecting information. So separate from the cost of developing or maintaining the information is the cost of providing information to those users who need it. They can also include infrastructure necessary to provide access and control of the information. And then value acquired from the cost of protecting the information. So also value to the owners, basically how much is your social security number worth to you, or basically your phone number. These are something that is value to the owners. And value of intellectual property, basically the value of that new product or service to the customer, sometimes is unknowable. How much would a cancer patient pay for a cure? Or how much would a shopper pay for a new flavor of cheese? And then value to adversaries. How much is it worth it to an organization to know what the competition is doing, basically? And then loss of productivity while information assets are unavailable. So, such as maybe a power failure. When that power failure occurs, maybe you have a UPS system or uninterruptible power supply equipment that can be prevent the loss. But basically the user, they cannot create additional information. And then loss of revenue while information assets are being unavailable. So maybe you are actually at a real store and your credit card doesn't scan. So maybe, and also maybe that then it would take a lot of time, so they have to manually enter it. Or maybe in terms of how much would the store lose if they cannot use that system, your credit card system. So that's the revenue that they could lose. So also, like for example, if you have an online store on Amazon or something, there's a power outage, they might not be able to buy that, so you will lose some money of that. So once the company has estimated the worth of various assets that they have in the company, they can begin calculating the potential loss from the successful attack of the vulnerability. This question might be asked: what damage could occur and what financial impact would it have on your company? what would it cost to recover from that attack, and in addition to the financial impact of that damage, and what is the single loss expectancy for each risk. A single loss expectancy, or basically we can call it SLE, is calculated value associated with the most likely loss from a single occurrence of a specific attack. It can take into account both the value of the asset and the expected percentage of a loss that could occur from that attack. So this is the formula for it. SLE equals asset value, or AV we can call it, times exposure factor, or we can call it EF. So where the EF is the percentage loss that would occur from a given vulnerability that is being exploited. So, and this is normally estimation. This is estimation technique that you will use. So maybe you can say a website has an estimate value of $1 million as determined by asset valuation, and a sabotage or vandalism scenario shows that 10% of the website value could be damaged or destroyed in such an attack. In this case, the SLE for the website would be 1 million equals to 0.1 or 10% times 100,000. So the estimation is then used to calculate another value, ALE, which we have just discussed. Usually the probability of a threat occurring is depicted as a table that indicates how frequently an attack from each threat type is likely to occur within a given amount of time. This value is referred to annualized rate of occurrence, or we call it ARO, which indicates how often you expect a specific type of attack to occur. Once we determine the loss from a single attack and the likely frequency of successful attack, we can calculate the overall loss potential per risk expressed as annualized loss expectancy, or ALE. So the ALE formula would be equals to SLE times ARO. So we said, so basically this is the formula that you can use. Sometimes it's a little bit hard to kind of understand this, but you need to kind of do more practice to understand this formula. The next formula that we're going to look at is the cost-benefit analysis formula. So the CBA determines whether the benefit from a control alternative is worth it, the associated cost of implementing and maintaining that control. A CBA may be performed before implementing a control or safeguard, or they can be performed after the control has been placed for a while. So the CBA formula is CBA equals ALE pre-control minus ALE post-control, or we call it the post-control minus ACS. So the ACS, we said ACS is the annual cost of the safeguard. So basically, we can say security is an investment. It's not an expense. So when we are investing in computer and network, security measures that meet changing business requirement and risk make it possible to satisfy changing business requirement without hurting the business viability. So other methods are out there for establishing the feasibility. We have organizational feasibility, that looks at how well the proposed information security alternatives have been. So operational feasibility refers to user acceptance and support, management acceptance and support, and the system compatibility with the requirements of the stakeholders. User acceptance and support can be achieved by doing a communication, education, and getting involvement. Technical feasibility determines whether or not the organization has or can acquire the technology and expertise to implement and support and manage these new safeguards. Sometimes the implementation of technological control can be very complex. So it is important to consider the technical feasibility. And then sometimes we have political feasibility that can define what can occur based on the consequences and relationships between the communities of interest, especially given that the budget allocation decision can be politically changed. So that's another thing that you need to take into the consideration, the political environment. And then other alternative approach to feasibility analysis is benchmarking, which is the process of studying the practices used in other organizations and then see if you can apply that. Due care and due diligence, when a company adopts a certain minimum level of security, that is what they're going to use based on their circumstances. Best practices are basically looking at the best practices in the industry and balancing the need to access information with adequate protection. And then looking at also government recommendation and best practices and see if that could match your organization. Also looking at the baseline by comparing measure actual performance against established standard for measured category. So this is it for this part of the lecture. In the next part, we are going to talk about recommended risk control practices that is being done in the industry.